Hello!
Hi, welcome back to Dad and Kids Coding, where we're working on the Advent of Code 2020. And we're on day 13. So day 13 is basically we're trying to find a bus schedule, trying to find a bus that leaves for the airport. And the problem is that we have a bunch of buses, and so this would be, the input has two parts. One is the time, if you want to think the minutes from some arbitrary point when all the buses start, that you need the bus, and then these are the bus numbers and also how long a round trip takes. So all the buses leave the depot at time zero, or I guess the port at time zero, and then the first bus, bus number 7, takes 7 minutes to go around its route and come back, or 7 units, whatever the units are. Second one takes 13. These are a couple buses that are out of service. This one takes 59 minutes. This one's out of service. This one takes 31 minutes and 19 minutes. So what we need to do is find out which bus will come back to where we are closest to, but before obviously this time. And the bus IDs, so here would be the various buses. So at the times around 9:39, these buses arrive, but it's before 9:39, so they do not help. Here we go after 9:39. Here's the bus that we're going to want. So it's bus 59, and it's going to arrive at 9:44, which is 5 minutes after the time we were aiming for. So the result we get is by multiplying that 5 times 59 to get the bus number, or to get the result that we're supposed to return. Okay? So, a pretty simple algorithm because really this is just the remainder. But let's work through. So I've added a couple of extra examples here. So if we were looking to leave at time 28, and these are the two buses, we got a bus number 5 and a bus number 6. Bus 5 is going to come around 5, 10, 15, 20, 25. And bus 6 is going to come around at 6, 12, 18, 24. So bus 5 is going to be the shortest waiting time before... oh, actually I've got the wrong number. This should be the next bus. So actually 28 is a really bad number because we want the next bus after the 5th arrival. It's the next bus, and after 28 is 30, which is both of the buses, and we were promised that we wouldn't have that case. So let's try a different number. So if we made this be 22, then the first bus that comes around after 22 would be bus number 6. So that would be bus 6, because it would come at 24, and that we would have had to wait for 2 minutes. So that would be 2. And then let's do this one. So 38 would be a fine time. And the next bus that's going to come around after time 38 would be time 40 when bus 5 comes around, because bus 6 won't come around until 42. So that would be, again, 2 minutes, and it would be bus 5 this time. So I think I got it right now. So let's save. So this is, what I'm doing is I'm creating a test case that should be much simpler to handle than this one. This one we're going to have, there's many more cases, and we're going to have to work through them. These two examples are pretty straightforward, so we should be able to find them quickly. And if we have to debug, if they don't get the right answer, then we can work through them. Okay, so as usual, we don't have a day 13a method, so we'll create one. And so the string that we're passed has these two parts. So let's get the time is going to be a string lines first, lines, And I could store this in a temporary variable and then buses. I can spell buses. Buses like that, I guess. And so I'm going to take, I'm going to split on commas the string that I get from split a string lines second. Because the input's going to be very short, so I don't have to worry about the fact that I'm calling a string lines twice. It's going to take us a tiny bit more time, but let's just save this. And time is a new variable, a new temporary variable, a new temporary variable. Okay, so let's just step over. And actually, we want to convert these all to numbers, right? Except that we don't need the, so let's just continue here. Okay, so buses is an ordered collection of the string 5, x, and 6, and time is 28. So we probably wanted to actually convert this to a number. So that would be better. And this one, we want to take this array and reject the cases where let's call it the field. If the field is equal to x, the string x, then we'll reject it. And we also want to then collect this with as number. Okay, so in other words, we want to convert them, we want to get just the buses that, so we'll step over. So time is the number 28 now down here, and so we'll just loop through this, and buses is now the numbers 5 and 6. So now we want to find the bus number that arrives the shortest time before the time. So what we want to do is we want to actually divide by the number, because actually we want the time closest beyond this time. But if we just take the time and divide it by the number, actually if we add 1, add the number minus 1, and then divide it by the number, we'll get the trip number of that, and we'll see which one is closest to the time. So let's loop through the buses. So, and we want a bus number. And then what do we want to do with this? We want to, let's take, so let's call it as the best bus and the shortest time. The wait time. Okay, now we should initialize these to something. What should we do? Well, once we have the buses, the best bus is going to be, we'll start it off as best is nil because we don't have a best bus yet. But what do we want for the wait time? Well, we want a time that we're guaranteed that any of the waits is going to be shorter than. And the longest time we could have to wait is the longest bus time. So if we said that that was the maximum time we'd have to wait. So if, in other words, if there was a bus that arrived it was about to arrive 1 minute after our, that arrived 1 minute before we arrived, then the next iteration of that would be that time minus 1 or 2 beyond that. So if we just said that wait time was equal to buses max, that would be worse than the worst possible wait time. Okay, so now we want to try, so we've got a bus, we've got a time, so we want to see if the time that we are looking for is shorter than the wait time. So if we take the time, the target time, plus the bus time, plus the bus number minus 1, and then we divided all of that divided by the bus number, and then multiply it by the bus number, we would get the time of the next bus after the target time. So if that is, so let's save that. This wait, and let's just add an X. So if this wait is that, and then if this wait is less than the previous wait time, then, so if true, then this is the better bus to take. So we'll say the best, just call it best bus, just to be clear. Best bus is going to be equal to this bus, and the wait time will be this wait. Okay, and then if I've got it right, then when we're done, we just return the best bus times the wait time. So I'm not certain I've got it right, but let's just, so best, no, I didn't want best. Where did I have best? I want best bus. Okay. So let's just proceed and see. And star was set to nil. Oh, because I didn't find a better bus time. So it seems. Okay. So best bus is nil. Okay. So let's restart. And step over these first. Okay, so now let's go into the buses. And buses is 2 items. So what do we have for wait time? Wait time is 6. So that should be the worst possible wait time. Yes, that makes sense. Okay, and then what we want is that this, oh, right. So this wait is not, this is not the correct calculation. So this should be minus time, because we weren't, so this is going to give us, so let's just evaluate this. So this part is is going to be the time of the next bus. So we're looking at bus number 5 right now, and the next time of bus number 5 will come along after 28. I got this wrong again? Just notice that this didn't get saved. Okay, save this. Okay, because I was wondering 28, that's the wrong number. So let's, well, let's just try and run it and see what happens. And I didn't add in the extra code, so that's okay. So we're back here again. So let's restart, step over. Yes, I have this really nice keyboard, but it appears that it is not doing my command functions very reliably, so I missed that it hadn't saved it. Okay, so back to where we were. Okay, so we're looking for the next bus after time 22. Okay, so times 22, bus is bus 5. So let's just look at this expression. And this expression is 25. So the next number 5 bus will come along that's after 22, will come along at 25. Okay, so that's good. But that's not the wait time. The wait time would be that minus the time. So let's just evaluate that. And that is 3. Okay, which is how much time we'd have to wait from time 22 up to time 25. So that's good. Revert, yeah, sure, you do that. And then let's just proceed and see where we get to. Okay, now the only trick is that I didn't have, there's a test that I should have done, which it would be to have this at exactly a multiple. So let's try 25, and this should return 5 times 2. 5 times 0. I think. Let's just go and see. So I don't know what the right answer is actually, because first line is the earliest timestamp you could have parent. It's a list of buses that are arriving.
Oh, I see it. Entries that show X must be out of service, so you decide to ignore them. I wonder what the second part is going to be comprised of.
Yeah, I bet there's going to be something to do with that. So I have no delay here, so I think this is 0. So let's see if I'm if I'm producing the right code, and B, save that, and proceed again. Okay, so that's the result I'm returning in this case. I don't know if that's the right result, but let's just try this. And so let's see. That's the right answer. Excellent.
There we go. We are exactly halfway through the advent code. 25 stars.
The shuttle company is running a contest. Yeah, fine. The earliest timestamp such that the first bus ID departs at that time and each subsequent listed bus departs at that subsequent minute. The first line your input is no longer relevant. Okay. For example, suppose you have the same list as above. An X in the schedule means there are no constraints on what bus IDs must depart at that time. This means you're looking for the earliest timestamp, T, such that bus 7 departs at T, bus 13 departs 1 minute after T, There are no requirements or restrictions on departures at 2 or 3 minutes after time t. That's what those spaces mean. Bus 59 departs 4 minutes after time t. No requirements. Bus 31 6 minutes after t. Bus 19 departs 7 minutes after time t. The only bus departures that matter are listed bus IDs at their specific times offsets. These bus IDs can depart at other times, and other bus IDs can depart at those times. Okay, we don't care about that. The earliest timestamp at which this occurs is a really big number, because we see at that point bus 7 leaves, and then a minute later bus 13 leaves, and then 3 minutes later bus 59 leaves, 4 minutes later bus 31 leaves, and 5 or whatever it is, 6 minutes and 7 minutes, this one leaves. And so what we want is the time of the first one when these all go one after.
Man, work days just keep getting longer and longer.
Yeah, that's a long work day, unless these are seconds or milliseconds or even seconds. If they're seconds, this is 10 days. So, or actually 12 days. Okay, so okay. There's so many bus IDs in your list. Surely the actual earliest timestamp will be larger than that big number. What's the earliest timestamp? Should all the listed buses depart at offsets matching their positions in the list? Wow. Okay. So. Okay. Well, let's. So that part A is done. That's good. Let's go to part B now. So.
It's shown on a red blob there, so
I
guess you should rerun the test.
There we go.
There we go. Completionist points.
Okay. So test A 13B. Okay. So this example has this big number as the answer. Equals that. Okay, and we don't care about this number, so we'll just call this x, just in case we mistakenly try and take the value. And we don't care about this number anymore, so we'll call that x. And we don't know what it's going to equal. But there are a couple more test cases here, so we can fill those in as well. So, let's just do a self-assert LC day 13B colon quote x I'm going to come back and fill this in equals something. Okay, period. Okay, so let's get this. So this is one of them, copy and paste there. And this number goes here. Okay. Then this one. Okay.
Huh. Hitting it harder did help.
Yeah, unfortunately, the keyboard is.
It's just like parenting.
Yes, we beat you every day. That works so well. Okay, and this one. The interesting thing is only a tiny change between these two.
Wow, it really does require you to like hit it a few times. Goodness gracious.
Yes. So all we did in between these two is switch the X and 7, and we get a very different answer. And the last one is this. Whoa. Come on.
It always happens on the third one. That's the weird thing.
It's just because that's when I stop. It's actually when I, oops, what I just do not know what to do. It's actually the one when I use my right, or use two hands for it rather than typing it one-handed. Seems to be what it is. Okay, so, wow. So, interesting. Huh. I don't know how to do this, so let's see. So let's run our test. And we don't have a day 13b, so let's create that in a code. So I'm going to just go and copy a little bit of the code from day A because, oops, this. Oh, it's as yet unclassified, that's why. So say both of these are day code. Okay, so day 13A. So we'll get the time and the buses, but we're gonna have to change some things here. So let's 13B. Okay, so we don't actually care about this first line at all. So let's just get rid of that. And this one, we want to split this, but we don't want to reject the x's now. We want to do something else with each of the x's. So we don't care about the intermediate times, we just care about the, so we need two pieces of information for each bus. One is the position, so we don't want to reject here. Okay, so we definitely want to split it up. And then we want to collect something. And what shall we collect here? So we want, given a bus, so I'm just going to say if bus is equal to x, if true, store return nil, if false, I'm going to return the bus number as number. Arrow. Yes. I want, not just collect here, I want with index collect. So now with index collect, it's going to give me a bus number and a index. And so if a bus is equal to this, then I want this and the index. Why is, oh, so this, there we go. And then I actually want to discard all the all the nils. Reject is nil. Okay, so let's, this is ridiculously long now, so let's break it up. And then we'll reject as nil. Okay. And it wasn't happy. Why was it not happy? Because it thought I needed another close parenthesis here, which maybe implied that I need one fewer close parentheses here. Let's see, where does that one match? That matches that. Okay. So I guess I don't need that one. Okay. And we've got some things that were not used, but that's okay. So let's add a self-halt here. The reason I'm doing this is because I'd like to have live data to work with, and I don't actually have the buses right now. So I'm going to go over here and rerun this now, and it's going to halt here. And let's see what buses is. So buses is an ordered collection with 17 in position 1. Yeah, just ignore that first X. 17 in position 1. Except I actually wanted the index -1. Then 13 position 3 and 19 position 4. Okay, so that's almost right. Except I want this as index -1. Because if we remember, over here, the first one we want to be at offset 0 from whatever time we're looking for. So how are we going to go about resolving this? So it's an interesting challenge. Because if we just iterate through trying to find a time that works, I presume it's going to take way too long. We could try that, I suppose, just to see, but I'm thinking it's not going to work. So what we want to do probably is try,
Alarms, huh?
Yes, phone alarms.
Not even once.
So what we want to do here is we want to if we take the largest time and skip forward in increments of that and try and find the So let's just try it that way. So let's say largest or step. So we want buses collect, and then we want just the key of from each element, and then we want the maximum of that, because we're going to step through this as quickly as possible. So take the max of that, and let's just get rid of this, and for now get rid of these, and step. Okay, so let's just proceed to the halt. Okay, so what is step? Step is 19, as we wanted, so it's the highest number. And so now if we step through in times for whatever that is, and then we check to see if all of them are within, or have the appropriate offset. I guess we need the offset for that one as well. So let's just do I'm thinking that we actually want this to be a dictionary rather than an array, but because we need to be able to look up this. No, let's just do it this way. Okay, so I want offset to be buses. Select. Okay, so I want the one where where the key is equal to the step. That's the one I want to keep, and then that's going to return me a list, so I just take the first of that, because there's only going to be one, and then I want the value of that. Okay, so I think this should give me 3. Let's just proceed. And offset is 3. Okay, so we've got the step value to use and the appropriate offset for that. Now what we want to do is to step through all the other, or step through in increments of that, seeing if the other ones are exactly divisible by it. So we're going to loop forever. So while true, we're going to loop. And hopefully find a place to stop while we're looping. So let's bring back a variable time, and so let's set time to 0. So time is equal to, I don't know, time is going to be equal to offset, because we're going to step through in increments of that. So time is time plus step. So now I need to go through all of the elements of our list and see if they have the appropriate offset from the time. So let's say found is true. So I'm going to loop through all of the buses. So buses do, and I have a bus keys and values do. Let's do that one. So I've got a key and a value, and if time mod key is equal to value, if that's not true, if false, then it means that this bus doesn't arrive at the appropriate time. Is that right? No, it's not right. Well, it's right, except so found is false. Okay, so let's put, save this. Okay. Found is temporary. Okay, now the only thing is I was wrong when I said I want time to be offset. I want time to be 0. So I'm going to advance by step amount, and then I'm going to see if no, I got it off by a little bit. So if found is true after this, if true, so the basic structure is right. Then I'm going to return time. Okay, so that's the basic structure, and it's basically right. I'm not sure whether this will work. It may run out of time, but I want to loop through while true, add the step amount to the time, and then see if the time I see what it is. It's time plus value. Value is equal, because what we're trying to figure out is will this bus arrive at exactly that point. So so the bus is going to come every key times. So it's going to come every 17, 13, or 19 minutes. and I want to know if that bus arrives at value minutes past the particular target time. And so for the first one, 17 is 0, and so it will work. Then 13 would be 2, and 19 would be 3. So we want to see if those times, when you take the base time and add the value, and this is not, yeah, right, and then take it modulo the repetition for this bus, if that's all 0. Okay, so let's save this and proceed. And that did not work because we time plus value. Maybe keys and values doesn't do what I had in mind. Let's go and look at it. Keys and values do. Oh, it's not a dictionary. So it's not a dictionary. What does it do? Sequential collection. Log. Oh yes, it's not all what we want. Okay, so let's look for the dictionary one. Yes, okay. So we need to make this a dictionary for this to work. So we'll just do it as dictionary. Okay, after revert, sure, revert. Now let's try proceed. Nope, that didn't work either. Okay, so let's see where we failed here. Step buses. Let's try keys. Does that work? Yes, okay, that works. So all we want is max, and we don't need the parentheses. Okay, so buses, keys, max is the step, and this is just buses at step. It's a lot simpler now that I've got it, have it as a dictionary. At step. And then it should work, maybe. Let's proceed. Let's see. And test took too much time. Okay, let's just save this. I was afraid it would take too much time. But where are we? We are in here, which is in here, which is here. No, we're still in the first one. That's not going to work. So, Okay, so let's restart and see if we could. Let's try and add a simpler example that we think would work. So so part of it is, do we understand this well enough to make a simpler example? So if I had 3 and 5. Okay, so if I understand this correctly, the 3 has to be in at a particular time, and the 5 has to be 1 past that. So I want I think that equals 9. Because the number 3 bus would come around at 3, and the 5 would come around at 5, which would be too high, too many. Then 3 will come around at 6, but the 5 will come around at 10, which is still 2, and then the 3 will come around again at 9, and 5 will come at 10, which is 1 more, which is, I think, the right value. So let's just see if this case works. So we'll step into this and see whether. So the nice thing about this is it should only go through this loop 3 times or something. So we'll step through. There's a better way to fill in this dictionary. I'll change it. But for now, let's just do this. Okay, so step is 5. That's the biggest step. And time is 0. So time is time plus step. Okay, so time is now 5. Which is good. And then buses, keys, and values due. So we're going to step through this and see what we have here. So time plus value is, oops, not what I want to do. Is 6. Okay, so and 6 mod 6 mod 3. No. Yeah, 6 mod 3 is 1, which is not 0. So this is going to be false. So we'll set found to false. Go through this again for the other one, but we're going to find found is false for that too. Okay. So we go time plus step again. So this is I initialized time to the wrong thing now. I should have initialized this to minus offset. Offset negated. Okay. I think I may have it now. We'll see. So we'll step again. Oh, let's just fix this because it's driving me nuts. So let's just say buses is a dictionary new, and then we'll split this is fine, but then we'll just do a do. With index do. And so I've got a bus and an index, and if bus is not X, then I will say buses at bus as number, put index -1. Okay. And then we don't need a lot of this other stuff. So we don't need this. And that means we don't need at least one of these parentheses. And that means we don't need this parenthesis either. So that looks better. So split the line, second line on commas, and then we'll loop through with the bus and the index. If bus is not X, then we'll set buses at bus number 2, index -1. Okay, that sounds right. Okay, so let's step through now. Just step over here. Okay, so buses has 3 at 0 and 5 at 1, which is what we want. Now we're going to step over. So step is the maximum, which is 5. Offset is 1. And we set time to -1. So we set time to time plus step. Okay. And time plus step is going to be 4. And then we'll loop through this, and found was not true. So now we add to step again, add step to 4, it's 9 now. And now let's see, let's go into this. So time plus value mod key should be 0. Inspect, 0, excellent. Okay, so we'll step through that. So we don't set found to false. And then we try again, and this time this is also 0. And step through. Again, we don't set found to false. We're out of the loop, and we return time. Time is 9. Okay, which is going to fail because our test assumed it was 10, but oh no, I had it as 9. Okay. So let's save this because it's correct even if it's not exactly fast enough. Okay, and test took too much time. Okay, and where are we in this process? D13B, let's go back to the test. Okay, so we made it through all of those and got the right answer. So at least we're getting the right answer.
Just not doing it efficiently enough.
We're not doing it efficiently enough. So buses, and what is time? Time right now is a really big number. And they did predict that it would be over 100 million or something. Way over 100 million. What is that number? Way big number. Okay, so, I think we're going to stop it here because I can't think of a more efficient way to do this off the top of my head. So
this will require immense studying in the annals of knowledge.
Something like that. So, so we've got the right answer now, and we've got a bunch of test cases, so that's good. Now we just need to figure out a way to skip through these faster. So, okay, so
well, I guess we're halfway through at least.
we're more than halfway through. We're almost done. We just need to figure out a more efficient way to do this. So thank you for joining us, and we will pick this up a little while later when we have some idea how to do this efficiently. So take care. See you soon.
Later.